Solution to example 8D from note 6.4, day 3. And we're trying to graph a sine function with multiple transformations. I notice that we have both a horizontal dilation because this coefficient in front of x is 2 and a shift. So the first thing that I'm going to want to do is I'm going to want to factor out the b value, the coefficient of x, and rewrite this as 2 times the quantity x plus pi over 4. And that'll allow me to have the proper horizontal shift when I do my analysis. Yeah. So we're going to begin by first finding the axis of oscillation. That's the midline of this graph. And because there's no vertical shift, the d value, right, I don't have anything here, plus or minus anything, is still going to be at the x-axis. So the axis of oscillation, I'm going to sketch that in. It's going to be at y equals 0. And I'll just write that's the axis of oscillation. Next thing we want to know is the amplitude. The amplitude in this case is positive 3. Remember, amplitude can never be negative. That comes from this 3 right here. That means my graph is going to move up 3 units and down 3 units from its own axis. Make sure you label the scale on the y-axis. I'm going to let each square be 1 unit. And then I'm going to go ahead and dash in the range, essentially. I'm going to put a line for the maximum values at y equals 3 and one where the minimum values for this sine function will fall at y equals negative 3. So we're going to have y equals 3 and y equals negative 3. That's going to create the envelope for our sine function. The next thing I want to determine is the period. A period is normally 2 pi, but here we have a horizontal dilation, actually a shrink. So the period is going to be 2 pi over 2 in this case, which is pi. Remember, the period is 2 pi over b, where b is the coefficient of x. And for our x scale, we are going to want to know the intervals for the key points. So the key points are at intervals of the period divided by 4, or 1/4 of the period, which here is going to be pi over 4. So we're going to want to use an x scale that incorporates pi over 4. And let's find the starting point so we know how to set up our x scale. The starting point, we're going to take an easy point on the parent function, which is sine x. So a nice point on sine x is 0, 0. And then we're going to transform that point. So we're going to see what's happening to x in our new sine function. So x values are going to be multiplied by 1/2 because of this 2. And then they're going to be shifted left pi over 4. So we're going to have to subtract pi over 4. So if I multiply 0 times 1/2, I'm still at 0. And then I subtract pi over 4 from x, so I'm at negative pi over 4, comma 0. And then let's incorporate the y transformations. So y, I don't have much room here. The only thing that's happening to y is it is multiplied by negative 3. So times negative 3, incorporating the vertical stretch by a factor of 3 and the reflection in the x-axis. 0 times negative 3 is still 0. So my starting point is negative pi over 4, 0. I'm going to set up my x scale by letting 2 squares be pi over 4. So let's call this pi over 4. Move over 2 more squares. 2 pi over 4, which I'm going to simplify to pi over 2. Count over 2 more squares. That'll be 3 pi over 4. 2 more squares would be 4 pi over 4, which I'm going to write as pi. 2 more squares, 5 pi over 4. And let's put some on the negative side. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and 2 more, negative 4 pi over 4, which is negative pi. And let's plot this. So we're going to start at negative pi over 4, 0. And now we have a choice since we're on the midline. We have to decide, does this graph go up to a maximum or down to a minimum? Normally, a sine function will start going up as I go from left to right. This graph is reflected. Okay, so this is reflected in the x-axis. So it will go down from the starting point. It will go down from negative pi over 4 comma 0. So instead of going up here, I'm going to go down to the minimum. So I'm going to be at 0, negative 3. And then from here, I can plot each of the points at intervals of pi over 4. I'm going to get the next key point. And I'll plot all those points on my graph. And then I will connect them with a nice smooth curve, the best that I can, which is a little bit hard on using this tablet. But your graph will look something like that.